This session is finding and exploiting access control vulnerabilities in graphical user interfaces, and your speaker is Colin Mulliner.
So, yeah, microphone's on. Yeah, good afternoon, everybody. Thank you for the quick introduction. And in fact, I'm going to talk about access control and the user interface. Just a little bit about me. I'm a researcher at Northeastern in Boston. I used to do a lot of mobile stuff, and this is kind of more or less my first talk about non-mobile stuff. And the talk is based on a recent publication I did together with two of my colleagues at Northeastern, Ms. Will Robertson and Engin Kirda. The materials like updated slides, tools, source code will be available at this URL. The white paper on the CD also has the URL. So, yeah, graphical user interfaces. I guess I don't have to say anything about it. Everybody of you is like using that every day. It's the de facto standard to interact with any kind of computer devices. If it's a desktop, a smartphone, some computer-based appliance, yeah, you basically use this every day. So, what I'm going to talk about. First, I'm going to go a little bit back and talk about some security history regarding to the UI, and really give you very basic overview about graphical user interfaces. Then just like talk about access control in the UI, introduce you to what we call gems or UI element misuse or instances of that, and then we show like how to automatically analyze application to find these kind of bugs, talk a little bit about countermeasures and conclusions. So, yeah, more than 10 years ago, there was this attack, it's called shatter attacks, which affected at that time, like I think all Windows versions, and this was the era of like 2000 XP. And the idea was you manipulate some part of the UI to like paste something into like a text field, and basically get memory corruption and code execution. And the target here was really to attack like OS kind of things to get really privilege escalation. So when you go from a normal user to a system user, and Microsoft fixed that. Now they have this user interface privilege isolation. So basically you cannot manipulate UI elements anymore of like higher privilege processes. But this talk is does not have anything to do with that besides that it's like targeting the UI. This is more about access control, which is like part of like applications, like enterprise applications. So, yeah. So graphical user interface is basically a collection of windows and widgets. On Microsoft Windows, a widget is a window. So they just used other terms, but basically the smallest element is a widget. Yeah, it is a base element. It means like the smallest thing you can address within a UI framework. And yeah, you all know like there's really common widgets like a window, a frame, a button, a checkbox, a text edit field, a drop down, a slider, and so on. It's really the basic things. All those widgets have attributes because you want to modify the behavior of like a widget at runtime. You want to have like a nice dynamic user interface. So one of the three common attributes are like you can enable or disable a widget, you can like hide it or show it, and you can change some properties. Like if it takes any kind of user data, you can like say, okay, this element can only be used to view data, or the user can only like look at stuff but not change it, or the user can also change it. And this is really built for making like nice, smooth user interfaces. For example, very common thing, you have a login screen, you have to type your username and password, and the login button is disabled until the UI sees, hey, there's actually stuff entered there. So like to give you visual feedback on how this actually works, like how you're supposed to use this application. And yeah, I don't have to say much about access control. It's like really one of the basic security requirements, especially in big enterprise applications. You don't want certain users to be able to see all data, manipulate all data. And yeah, like some examples are like, for example, you have some database-driven applications. You want one user can like create or add data, others can only view or modify or access like privileged functionality, like, hey, let's dump the entire database. You don't want all your users being able to do this kind of things. And yeah, so in some of the access control stuff, it's like really tempting for developers to like just implement this in the UI. For example, very easy application. So some inventory, it's a very basic application, but very perfect for explanation. So this is like a multi-user application, as you can see down in the middle. The user number test1 is logged in, and this user cannot create new articles. The button is disabled. So this is very likely used for access control. Yeah, but widgets can be manipulated. That's like really the basic feature of any UI framework. And with manipulated, I mean you don't have to like modify the binary or like attach a debugger. The UI frameworks provide the means to change the UI from outside of the program. So basically, if you can manipulate the UI or manipulate the widgets, you can bypass access control. And I have a very short demo to make this a little bit more clear. So let's see. So same application was just showing you. Maybe I'm not a user who's not allowed to use this application, so I don't have any user credentials. But maybe this application was really abusing the UI. Let's see. Oh, so this application apparently is like drawing all windows, but just hiding them from us. And here is our here like all user accounts of this application. Just to show you, who remembers any user and password combination? I'm pretty sure it was test and 1, 2, 3. 2, 3, 4, 5. So yeah, now we could log in. Yeah, whatever. Okay, so very basic. So this application was obviously abusing part of the UI framework to like hide screens or part of the application from you if you're not privileged to actually see this. And this kind of attacks like have been like known, but nobody really ever looked into it. Of course, you say, oh, I know you can like enable this button, and then maybe you can like turn this like demo version to like a full version. But yeah, there is no like what documentation or like research on this whatsoever. And we like sat down to really go systematically investigate what kind of like problems UIs have. So our like basic research contributions is like we introduced like this vulnerability class, which we call gems. We define or we've discovered 3 different classes. Basic information disclosure, unauthorized information modification, and then callback execution. Yeah, we developed this tool and this analysis technique we call gem miner. And then we like tested a bunch of applications and found a bunch of bugs in commercial software, and we're releasing some small tools, including source code today. So let me talk a little bit about the threat model. So this is really about applications with internal user management. That means an application does not rely on the operating system, but because maybe you have like some, CRM system where everybody has like the binary on their system, and you have a credentials, log into the system, use the system, and log out again. And it's not based on the OS user management. And of course, there are accounts with different privileges. So as I said in the beginning, like reading data, writing data, executing privileged operations. And those applications are like normally found like in the enterprise domain. Applications that like manage data and which like commonly like require access control. So this class of bugs, we name them UI element misuse. So basically you're misusing UI elements to like do stuff you were not supposed to do with them. In this specific case, implementing access control. And so if you have a gem vulnerability, you basically have an access control bypass vulnerability. Yeah, so 3 classes are like unauthorized, what I said, callback execution, data leakage, or data manipulation. So when you look at the first one, the unauthorized callback execution, normally how UIs work, you have some UI element, and if you activate it for clicking on it or like focusing it, pressing enter, what you normally have, the click of the button or the activation executes a callback that then performs some operation within the application. And here developers really assume that if they disable that element, the user cannot interact with it and cannot like make or have this code like execute. And the attack would be you enable the UI element, then interact with the UI element, and that's how you get to execute the callback and perform whatever operation you wanted to perform. So, another demo. I'm going to use this application once more. So let's assume we are this user, and yeah. So this button, as you can see, we cannot. And this is not active. So I'm using a tool which is like normally used for UI development and testing, which basically just allows you to inspect and modify UIs. So you can very easily just select there we go. So very easy. So see this flashing. So this means this is the button. Now you can just say enable this button, which you can also just do. Like you can have your own tool, which is like way easier. Just like really shows you like that's like all this stuff is accessible. Now this button is enabled. It wasn't redrawn in this case, but yeah, we can just click on it and we got the functionality. Like very, very, very simple, but effective. Yeah, so a little bit about this tool. This is like not a tool I developed. It's a UI development and testing tool, but they provide the source. You can easily extend it, and I'm going to later show you some extension that we're going to release. So the second class, the unauthorized information disclosure. So basically, you have an UI element, and you use it to store sensitive information. And the idea is the UI element, for example, the window with the account management, is not shown to you if you're not a privileged user. Yeah, and the assumption is, hey, it's shown, the user, unauthorized user cannot see it, so it's all good. The idea for the attackers, you set the element to visible, and then the UI framework will just like nicely draw the UI for you. And yeah, you can just like inspect it or with your own eyes see it. Or if you have a specialized tool, you can just like directly access the window and just like write it to a file. So this is another demo with like a tool we developed ourselves. Let's see. It's the same. Basically, it's the same tool I showed you in the beginning. I'm just like going to tell you a little bit more about it. So we are back to the screen. This time I'm gonna make it look more legit and actually use a shell, because that's what you have to do in order to be taken serious. Even if you do a talk about UIs, you have to use a shell at least once. So I have this tool. This is a little bit readable at least. So basically I run this command line tool, pass in like the name of the exe file, so which is in the, and then you will see the same thing over again. Let's close this. Oh, maybe not. Is it not closed? Anyway, that's why. So yeah, when you like heavily mess with applications, they sometimes don't like that. Where's my desktop? There we go. That's why we have this dude here. It's quickly gonna kill. Yeah. And so So as you see, yeah, sometimes like the programs totally clutter up, but we just want to like see what the program actually has for us. And in order to look at the stuff a little better, the tool does not only like show you the screens, but also will like take screenshots of everything. So now you can just like go here and just like go step by step through the whole application. Yeah. And like, so these are actually not bugs. This is just like UI artifacts that are just like sitting somewhere, and then later going to be moved somewhere. So you see interesting screens like this. So this might have some future value for us. But now we can just like go through and say, oh, this is the thing we're looking for. Much more convenient than like moving around like all these windows. So going through this like WinSpy application to like click at every screen. We just like look at a bunch of images, and you can really just like sit there and like press space until you find something. So very easy. So this application obviously, yeah, things like hiding stuff in a window and just like making it invisible is a good idea. Yeah, and this tool, including SOR, I think I only have on the CD only has the binary, but the source will be on the website. A small variation of the like the normal information disclosure is what we call this dangling information disclosure. Here the basic idea is that sensitive information is not scrubbed from a UI element after the UI element is no longer used. So for example, if you have an application, you're a normal user, you change something, then you see, oh, I made an error, but I cannot revert it. So you get maybe a supervisor, somebody with higher privileges, we're going to temporarily like escalate the privileges, revert your changes, and then drop back to your user. And if the application doesn't remove that UI element, you may have like leftovers there. Maybe data the privileged user was able to see, or maybe things like the password from that user. And the attack is basically the same. You just basically go back and just say like, show me everything that's like hidden, and then you can see yeah, if there's hidden stuff. And we found a bunch of those. I'm not going to demo this one because the next one is way more interesting. So seeing data, like getting access to stuff to like look at is pretty interesting. But if you could like change data without having the privileges, much more interesting. So UI elements, especially like text edit fields, can be changed to be read only or read and write. And the application, the idea of some application, the application develops is you basically bring up a screen, fill all the fields with data, and as soon as the screen is closed, so you press OK, you're safe. You just take everything that's currently stored and write it back to the database because, hey, yeah, we know if the user had the rights, then there would be changes. If the user didn't have the rights, no changes. So we can just like do it anyway. So the attack would be you change the value of the read-write setting or just change the data directly, just depending on how the UI framework works. And then you just like click save or maybe enable the save button first and then click it. And with this you can get some nice write privileges. So I'm going to first show you how to really easily discover this fact just by looking visually at the application. So we made a tool. Basically, we modified this WinSpy application to give us some additional information about the application. This application is a bit slow in this VM. It should start any second, hopefully. First we start this one. Come on. we go. So this is like a submodule of a CRM application. So let's first log in. This application does not have the bug where we can like just show us all the accounts, but that's okay. It's really slow. Finally. Okay, so this is basically just like a contact management submodule of this application. This is basically all like list of contacts. And let's try to look at one. So this is basically, it's a Swiss thing. So this user is obviously allowed to change certain things, but like not like this thing. So this you could tell by just trying it out, but it's pretty boring. You want to have a quick overview of what is happening. Oh wait, I can actually close one of those. So let's press refresh. So we have this application running here. I select this window, which should be this window. And now we color the screen. So basically it just like looks at like inspects the UI and then says, okay, which text fields are read-only and which ones are read-write, or which widgets. As you can see, the top one, is read-only. And this like number down here is like a read-only field. Everything else we can just read and write. So this is the green markings is really just an overlay. And with that, you don't have to like click around and look at the UI and try. You just in 1 second you see this user seems to have a lot of privileges. So let's restart the application. And come on. This is the last time I have to start this particular application, so. See. Come on. Oh, there we go. So let's go user 2, which surprisingly has the same password as user 1, but user 2 doesn't really know that. I always thought .NET was like super fast, but.
Does this apply just to applications or also to web applications?
This is, web applications have, I would say, very similar problems, but everything works completely differently. Also, I'm not really a web applications guy. So here we have the same screen. But this user, I'm trying to type here, we cannot change anything. But let's refresh. Go here, we selected the right one, and then try to draw the layover, and we see, hey, all of those fields, which the other user could change or had like a green box around, are red here. So we very easily see, okay, hey, those fields have different properties. So they could be a problem. It doesn't mean, hey, this is like definitely access control related, but it gives you like very, very good indication without doing any manually testing. Okay. So I could have just shown you this page, but it's was kind of boring because. So here really you see on the left side you have like the low privileged user, and on the right side you have like a higher privileged user, and side by side you really see the difference. You just like immediately see, okay, there's a difference here in the UI. So a little bit of like more like the technical parts before I go into like how to like find those stuff out in an automated way. So applications basically have to be executed by the same user as like your attack tool. So basically your employee who has like the low privileges, he's the guy who wants to is trying to attack you or attack the application. Because all of the interaction is basically IPC between your application and the other application. And the steps are really you have to discover the UI elements, all the widgets, obtain like a window handle, and then like send a message to it. And all of this is really done through like very, very basic Win32 APIs, like the send message family, like enable, disable, window enum childs. So you just like get all child windows of an application. And then you can just like is this window enabled, visible? So you can programmatically, you can access all of this without like having to like the user sit in front of it, like inspect everything manually. And all of this stuff is like very, very well documented. If you want to say, how do I enable a window? How do I hide a window? You just like Win32 enable window, and was like, here's the source code. So it's like very, very straightforward. That's why I don't have like any code snippets. Everybody can use Stack Exchange, I'm pretty sure. So a little bit more backgrounds on UI frameworks. So as I said in the beginning, on Microsoft Windows, every like basic UI widget is called a window. And basically everything is a window. So a button is a window, an actual window is a window, a text field is a window. And it's like very basic functionality, hide, draw into it. And so other frameworks like .NET, or like, if you have some Delphi library that like runs like on Windows, they basically use the basic Windows, but they have their own drawing operations and their own methods to like get feedback from the user, receive input. But everything basically is a window. So you can access all of that through like the standard API that I just showed you. So some of our applications were .NET applications, and .NET really like it's all how do you call those things? Non-native stuff, managed code. So it's all the managed code, but they still have like, of course, native libraries that then use the Win32 API to actually draw windows. So the Win32 API can also be used to see those widgets and manipulate like the very basic things like the visibility state and so on. So as an attacker, you can either use the Win32 API and have like very basic access to everything, no matter if it's like .NET or Win32 or whatever. And it's really enough for most attacks. But if you want to like have more sophisticated or more detailed access to what's going on the inside of an application, if it's like not a Win32 application, but like a .NET application, for example, you just use like the .NET API to like send specific commands to specific kinds of windows. One very easy example is this button bar from one of the applications. Win32 sees this entire black box as one button, while .NET says, hey, that's a button bar. This is like 19 buttons. But with the Win32 API, you could only address the entire thing. For us, this was like, not really an issue for our tests, but more sophisticated attacks might like need to incorporate like UI framework specific functionality. What I would say before I go over to our automation part is like the two cornerstones of the UI vulnerabilities are false assumptions by developers. Developers say, hey, or at least some of them say, hey, the UI cannot be changed externally. Widgets are widgets and their attributes are like protected from manipulation. But on the other side, the other part of gem vulnerabilities are that it's like really easy for like non-sophisticated attackers. Basically, if they have the right tool, you can point and click. You say, hey, this button is disabled. I want to click on it. So just enable this button and you're set. You don't need to be able to reverse engineer or read binaries. You don't need to tamper with files on the on disk or like write your own network protocol implementation. So you can really attack the whole application completely black box. It's like really, really easy to carry out. If you know how to use a computer, you can like do this kind of attacks. And I would say like I had a discussion with somebody about this recently, and he was like, yeah, but you can, I just like reverse the stuff. It's like, hey, I bet I can do the attack while you're still, I'm done with my attack while you're still searching like for the location of the binary on disk, because it's just so easy. So with this, I'm gonna switch over to our to like the formal like analysis method we came up with. Because if you have applications and you want to like see if this application is like vulnerable to this, you don't want to manually audit the application. You don't want to sit there in front of it, like click a button, look at the screen, take a snapshot. It's just like tedious, and if the application is a little bit complex, you will miss something because non-automated stuff just is not working on a larger scale. Also, you rather like want to like drink coffee and like go back and then look at like results. And the whole idea is to like do this black box analysis in a black box fashion, because then we don't need access to source code. We don't need to like reverse engineer stuff. Just make things easier. Also, then we don't need to care about if this is like a managed .NET application or a native application. So our system, which we call Gem Miner, basically you put your application under test in on the left side, and on the right side you get out your gems. So how is this actually working? So we have like 3 phases. In the first phase we have like a part which like explores the application and like records like how the UI looks like. If you remember the screen where I showed you the two settings with like readable and read-only text fields, this is the kind of information this program automatically records. And then we identify some candidate widgets, so widgets which might look like they're like being abused for access control, and then we have a step where we actually check and like do actual attacks, automated attacks against the application, so we can say, this looks fishy, yes, this is like, this is like an access control bug, or no, actually when you enable the button, you still get a pop-up which says you don't have the right privileges. So when you do want to do automated testing, you have to like, of course, create the user accounts. You have to like do some basic seeding, because when you install an application like this, there you don't have user accounts. And if you don't have user accounts with different privileges, you can't find this kind of bugs. So you also have to like add some data, because in order to like detect like data leakage, there has to be something your tool can actually find, because even with, just like if you have like this awesome SQL injection attack, but the database is empty, it's not really something you can like see besides maybe an error message. So really have to configure the access control privileges, restrict one account and give like a lot of privileges to the other account. That's like the best way. But you can also have 10 different accounts if you want to see if there's like subtle differences. Then you just have to like do more runs. So in the exploration stage, basically you have a basic tool that will like click on UI elements, and then just like record states, And basically what we tell the application or a testing tool, run this application, use user A with password A, run it, record everything, record the interactions too, because we want to know how do we go to a specific screen. I first press this button, then press this button, and then I get to the screen. So all of this is completely recorded. And then you do this exploration for each of those privileged levels. So if you have 2 users, you run this basically, you run it twice. And then you have a set of your states for each privilege level. And a state contains windows, they contain widgets, and all of the attributes from all windows and widgets. And then, so these UI states and then candidates. And basically, you compare two states, and I have 3 example widgets. So the first one is a button. So you can see, then the element type is this is a button. And this is the example from the first slide, from the very beginning. This is new article button, and you see the low privileged user. For him, he sees the button, it's visible, but the button is disabled. And the high privileged user, for him, the button is enabled. And then we go to the next example. It's a button again. The button takes this help, so it's probably we'll just open you the help window, but you see both the low and the high privileged users both are able to read the help, of course. So probably there's nothing to, there's definitely nothing to be found there. And then we have this text edit field, the third example, where you see the low privileged user, it's set to read only. And for the high privileged user, it's set to be read and writable. And all those widgets which have different attributes and different privilege levels, those are our candidates. Those are the widgets which are potential or have the potential to be a UI element, misuse case. So those go into this collection, and we just have a list of widgets, and each candidate basically have a widget ID and type. So this is a button, number something. You have a path, so you know how to get from application start to the screen that contains that widget. And maybe for some, depending on the widget type, you have a successor. So if you know, if I press this button, a new screen with title and hello appears. And stuff like that, we record, and then the checker basically, it executes the application for each of those candidates. Then it drives the application, it does all the operations to go to the specific screen, and then it manipulates the widget, and then it checks the result for that. For each of those gem candidates, we have a different testing strategy. For example, for a button, we see, hey, is this callback executed? So if this is a screen appearing, or for information disclosure, or we basically say, hey, can this widget contain data? And then for the information modification, we can see if the application accepts the data. I'm going to tell you a little bit more about the actual testing. But all the testing is complete black box. So our application only interacts with the test application using the UI. So, because with that we can be very sure that this is actually a bug that can be exploited in that way. And the tests are really completely independent of the application. So we have a test method for buttons, and that works on all applications. We don't need to know anything about the application. So for the callback, it's as I said, very easy. If we activate this, click it, does a new window pop-up appear or not? That's the basic testing for that. For information disclosure, it's we don't really actually do actual testing, because we see, hey, this widget is always hidden in the low privileged mode, but it can contain data, and it's visible in the high privileged mode. So we say, hey, this could be a case. So we just dump it to the output and say, okay, this might be something. But so for the data modification, it's a little bit different. And I'm also going to show you a demo for that. But basically, or for the attack, if there is time. But basically what we do, we drive the application to this window, say, okay, we want to change this, or we want to like test this candidate, so the price. Then we just say, okay, set this to this field to read write and change the value, and then we just like close the data, close the window, and we just have some basic heuristic. We just like look for buttons that have like words like okay, save, next, and then we just like click it. And then we go back to that screen and see actually if our test value is displayed to us, because the application could say, yeah, whatever, it doesn't throw you an error, but doesn't accept the values, and basically, yeah, it's not working. But if you like open the window again and hey, the test value is in here, then we actually see, hey, the application accepted that, and it didn't detect the manipulation, everything is good. And in a second step, or in a second step, we do the same test, but we close the application after doing the initial manipulation and just like restart it, because maybe it was like saying, okay, I will have this in memory, but because I'm confused, I'm not writing it to disk or to the backend. So in the second step, we stop the application, restart it, do the same thing again. If our test value is still there, we say, okay, this seems to be legit. We'll say, hey, this candidate is confirmed. You know, like we can manipulate this and this will stick. So as a result, we no longer have hidden gems, but we have a list of gems, which is basically a widget type, the window, and the path how to get to it. And with the equip is like a list of gems, you can then go to the application and exploit it. So let me first, how is the time? How many more minutes? Okay, awesome. So let's do a demo. So this is basically, you remember this application, we cannot change anything here, but you can pull up this thing, refresh, go here. Let's see, which one is this? There's a flash. Yeah, so this is this text field, this one. So let's change this so we can just say so now it says hi black hat, and we close this, and then we can go look at this, and it's still here. So, but we can actually normally not change it. So very simple. Yeah, so very easy attack if you know what you have to do. Yeah, so in the end, then we have like this list of widgets, and then you can go and like, hey, this button, this field, change value, done. So we looked at a bunch of applications, like an inventory application and like some small employee and product management thing, and then this like Profix is like a CRM, some CRM thing from a Swiss company. And actually the two first applications were like plain Win32 applications, and the last one was a .NET application. And yeah, so we found a bunch of callback bugs, so like buttons that were like disabled, and you could re-enable them, and then it's like, for example, dump the database. And actually this specific application like had like, you could basically enable every button again and use it, but there was one button for like to go to the settings screen. We would enable it, click it, and it would just bring you a pop and say, hey, you're not the administrator. So they thought about, they have some kind of security in the application, but like, hey, you can dump the entire database if you enable the button. So it's like really, they thought about some of it. Probably this like, this check was probably not due because they were like checking for UI stuff, but they had like some check somewhere where they said, okay, you have to check first if you're the administrator in order to like change the settings. So those are like these candidates where we actually try to exploit them, and then we see, okay, there is like another window coming up And then actually our automated tool takes a screenshot, and then we can easily go back and say, hey, this was an unconfirmed candidate. Let's look at the output. And the output says, hey, you're not the administrator. You say, yep, this part is not exploitable. And yeah, so this information disclosure bugs. So that's the application you saw like multiple times now. When you start it up in the beginning, it just like draws a bunch of screens, a bunch of windows, and just hides all of them and just shows you the login button, the login screen. But yeah, if you just like make all windows visible, you will get like the account management view. And the same application had like exactly the problem where you like log in as a normal user, escalate to admin, and go back, and then you can just like look and just go to the UI, just like say, hey, show me all text fields, and you would see, hey, there's the admin password still in there. And then for the information disclosure, for the information modification. So this application was using read-write, the read-write attribute on text fields to control like write access to the database. And like all those red boxes are the disabled fields. And some of the unconfirmed candidates here where a field could not be changed was because it was like relating to some other field. So it had to like match up to a certain input of another field, which is kind of hard to detect if you don't want to like check everything against everything. But then you can just like easily flag it. Also, also there was like 2 fields, I think, that only would take GPS coordinates. So if you don't like test for valid GPS coordinates in your input, then you won't find it. But that's stuff you can easily do manually afterward if you only have to like look at 5 and not like 5,000 different widgets. Since I have time, I can like tell you a little bit about this like application. So we actually, of course, try to report all the bugs. And this company actually said, oh yeah, thank you. And it's like, so what do you think? And it's like, we don't think it's a problem. And said, are you sure? And then apparently they talked to like engineering, and they said, oh, we based our entire security model of this application on the fact that we can protect, or like widgets are protected. And they more or less said, okay, we cannot fix this. But we're doing a redesign anyway soon. So they will like incorporate that into their redesign. Which is a pretty interesting thing, because those kind of bugs is like, it's not you have to like, oh, I have to just like check, add a length check to like something and just recompile. If you don't have like access control in your application, that is like that actually like really works, and just say the UI will just like take care of stuff, and then you actually have to like change a lot in your application, add like a complete new like layer in your application. So in summary, I showed you that what gem vulnerabilities are and that they exist in software. And in my opinion, they can be like really easily exploited by like non-sophisticated attackers. We built this analysis tool to like automatically test applications. And the test is like really independent of the UI framework, as long as you can like address like the base widgets. The system, we managed to like automatically find a bunch of bugs. It's right now it's obviously implemented for Windows, but I think you can like port it to some other operating systems. And actually, we also looked a little bit at other operating systems. Basically, the 2 basic things you need to be able to like have gem bugs or exploit them. So it basically means you must be able to inspect the UI of another application, like while it's running, and you must be able to manipulate those UI elements. If a UI framework supports this feature, you basically can exploit gem vulnerabilities. And I built like a very small proof of concept for GTK Plus on Linux just because it's like so completely different. Yeah, and here the idea is like there's like no generic UI to like talk to any API to talk to any application. But talking to an application on Windows is basically you have an IPC and you can only talk to the application if you have the same privileges as this application. So if the application runs on a higher privilege level, you cannot like manipulate the UI. So it's basically the same on Linux. So if I can just like I can load a library into the program and then just like access the UI and just iterate through all the UI elements. Of course, so if the application would be set UID, so if it would be executed as another user as root, I cannot do LD preload, so I cannot like talk to this application or I cannot like send IPC to that on Windows if it would be running as another user. And then you just like discover all widgets and modify attributes. And yeah, I did a basic program that like would disable some stuff, load the library into it. This exact same deal. Yeah. Yeah. So we also, of course, looked a little bit into countermeasures. Of course, the basic message is that application developers should not rely on the UI framework. And like, for example, you should not store like runtime data in the UI element and then just say, okay, I will show you this. I have some runtime data. When you close the screen, I just like pull the data back and I don't have to like keep track of this stuff anyway because the UI is going to do that. And you should really treat data stored in widgets as untrusted user input because the UI framework is really not protecting anything. So if you store something in there or not store something in there, just because you say nobody can manipulate it doesn't mean like when you like read it back, it's still as you left it. And you should really create and destroy widgets and windows as needed. So you should not say, hey, I have those 500 windows. Let's create all of the basic ones and just like make them visible. You should really create a window when you need it, get the user input, and then, yeah, if you no longer need it, for example, after the user logged in or logged out, just create the window because then the operating system and the UI framework will just like, yeah, freed up the memory and it like the stuff will just go away. And yeah, one small fix is like we said, okay, you could just like remove, and instead of disabling a button, you can just like not put it into the UI in the first place. Because when another user logs in, you're just gonna like draw the screen again, and then you can just add this button. But this is like only a partial fix because you cannot fix all kinds of bugs in that way. Yeah, if you happen to have like an application that actually has this kind of bug, one of like a really easy like hotfix would be, hey, you can just like configure this. The administrator can like configure this application to be always like run as another system user. So when your like employee sits in front of it, he can use the application, but it runs under like a different system account, and then you can just like not do IPC to the application. You cannot send messages to it. This is like a total hotfix and like a hack, but this will actually like prevent exploitation in that way. Yeah, and with that, I'm at the end. Yeah, so I introduced you to the UI element misuse or gems. I would say it's a kind of a new security class of security vulnerability. I know stuff like generic like UI attacks have been around for some time, but nobody like so far like really tried to look into it, like classify some stuff. Yeah, we found this like 3 classes of those kind of vulnerabilities. So unauthorized information disclosure and modification, and this unauthorized callback execution. Our system that we built like works pretty well on Windows, and we discovered some unknown bugs. And I think it's like a good first step to like include the UI more into like the testing. So there have been other tools which would like interact with the UI just to like test the actual application. But what I'm saying, you should like also test the UI as part of your security evaluation if you look at do black box application tests. For our work, we specifically addressed like access control vulnerabilities. Maybe there's like other kinds of like UI related vulnerabilities. But yeah, we did this first step and like looked at this UI, this access control stuff. And with that, I'm done. The tools, source code, and updated slides will be available at this webpage. And I'm done. Thank you for your attention. And if you have any questions, I think I have enough time to answer some questions. Thank you.